lights out or even under the covers if it gets cold.
Hello. Just sitting up. Testing. I think that should be fine. I noticed yesterday my audio was a bit too low. Just setting up some windows. Just setting up a nice way to view the current music playing. OBS is fun. I really like playing with OBS. Alright, hang on. Oh. Well, it was working for a moment. I like doing this on the I like doing this on the stream because then people kind of see me setting up, and it feels like more of a community. Yeah. But I tell you what, it's an awkward it's awkward trying to crop things. Today we'll be programming my Twitch avatar. Oops. Okay, I think that's about it. Close. What was over here? Put them over here. But should I put it over here? Should I put it over here? Hang on, I'll just view my stream on my other computer to see how it looks like. Yeah, I think it works for now. Whoops. You weren't meant to hear that. And here's my cube. Oh! Oh. Okay, there's probably a... I'm gonna check that. I'm very bad at spelling, so I'm gonna check that. How you doing, Sly Slime? I don't think that's how you... I don't know if that's how you pronounce your name. How you doing today? I can't read emojis. So. Chilling. Nice. Hey, do you hear the storm today? It's quite stormy here in Auckland. Right. Let's check this bio. Psi, okay. Use Psi settings. Yep, I misspelled noob. Fixing that now. Dyslexia is not fun. Luckily, I have a new keyboard. Well, I went to work to pick up my ergonomic keyboard, and my typing's a lot better. So, that should make today a bit faster. Still, just making sure that all my accounts, all my work accounts, are like turned off, so that no one sees what I'm who I work for. Don't want to accidentally break an NDA on stream. That would not be good. Okay, almost there. We got the copyright-free music. I've tested audio to make sure audio works. I think we're ready. Okay, let's begin. So, So, welcome to my programming stream. I hope you're having a good day. I hope you're excited to learn a bit about Unity programming today. I'm excited. Oh. I think just want to check chat now to see if my chat window is too big. Always finer things to do. Yeah, I have to make chats a bit smaller. Think. Yeah, there you go. Okay, I've resized chat, so now it should. Okay. Yeah, so today we'll be doing my programming stream. I'm going to be progressing my avatar. We have a nice cube. We have a nice cube that looks around. Like that, which is pretty cool. But we need to start working. We need to make it look. We need to make it feel smoother. We need to add eyes. We need to add a mouth. So that's what I'll be tackling today. Hope you're enjoying today. I've given myself a proper breakfast, so hopefully I can keep the energy up. Last time I did a programming stream, as soon as I finished the stream, I collapsed into bed and just fell asleep. So hoping that doesn't happen this time. For breakfast I had 2 eggs and broccoli and cauliflower and a coffee. And the reason why I did not have toast is because I'm trying to get back into keto. Bread has carbs. Yeah, and so like, you know, with the broccoli and cauliflower you get a lot of fiber and a lot of nutrients, and with the eggs you get a lot of saturated fat, which is actually good for you, and you get protein. And there's some carbs in the coffee, but I'm trying to get back into keto, and I can't go super hardcore keto just yet, because what happens with keto is when you start keto, you'll have a bit of keto flu, because your body's used to glucose, and when you start eating keto, you'll have whole meals, but then you'll be starving. So when you're starting off, having a little bit of sugar, having a little bit of carbs to like keep the keto flu at bay is actually pretty good for you, as long as you don't overdo it. Anyway, so as you can see, we have a nice cube here, and the cube is steering where my mouse is, which is pretty cool. And you also see the cube in the bottom right is doing it as well. And that's because I'm running OBS out of my builds. My actual build here, I'm running OBS out of it. And so like, if I was to change the color of my cube, so let's change the cube material from white to like, let's make them orange. There you go, a bit of orange. So now my cube's orange. So if I hit compile, yeah. Hang on. Yeah. So it should override the cube. Did it override the cube? No, it didn't. Why didn't it? Failed to prepare target build directory. Is a built game instance running? Yes, it is. Okay, that's easily fixed. We'll just what's its name? Its name is Twitch Avatar. Here you go. Here's a process running here. Twitch avatar.executable. We're in that. And now if we run it. Oh, where do we build? And now my cube in the bottom right is orange again. So yeah, we have a bit of an awkward pipeline to update our cube, but that's gonna be fun. Anyway, so today, first thing I want to focus on. Let's write. You know what? Actually, let's write it here. So I'm going to open up my C# project here using VS Code. Boy, do I love VS Code. VS Code is my favorite programming language of all time. No, what am I saying? It's my favorite development environment. I'll just change the theme here. And I'm just going to check my... nah, it doesn't really work. Hang on. Theme. What's a good theme? Is there a good theme? Nah, I should stick to, what about Tempest Dark? Nah, it's not good enough to look at. We'll just stick to Visual Studio Dark then. What I will do is I will make this bigger. But what about the Unity? Yeah, you know, I'm going to open up the display settings and I'm going to make it easier to view. So display settings. Okay. That should have made things a bit easier, but now I have to readjust everything. Yeah, that looks good. And that looks good. Yeah. So let's go back to OBS. Okay, now we just have to reposition the chat in OBS a bit. Chat. If you go across like that. Make it a bit smaller. I think that's good enough. Oh, we'll just move him a bit over here a bit. On the main. Move him up a bit. Make it a bit smaller. Yeah, I think it'll work. Spending half a stream actually setting up the OBS stream. Okay, I think we're good to go now. So I think that's legible. Yeah, I'm hoping Unity's quite legible for the stream, eh? The only issue is chat covers the inspector. So I might actually switch this around. I'll put the inspector on the left, lighting on the left, hierarchy on the left, put the game on the right, put the scene on the left. Yeah, I think that. I'll put console on the right. Actually, what if I do this? Whoa, whoops. Go away, Asset Store. There you go, look at that. That lines up pretty well. You know what, in RBS I might just add a transparent darkness to the chat. Sorry for the delay, guys. I'm just trying to make sure everything looks nice. But again, I like sharing this process with people on stream because like I'm hoping to like build a little bit of a community here. So in chat, what we'll do, no, go away. I don't want to show my emails on screen. Okay, so I'll create a solid color. Color sort? No. Color source? Make it dark. Okay, but it goes behind chat.
Sometimes wind, sometimes rain. Then the sun comes back again. Sometimes rain, and sometimes snow. Goodness, how we'd like to know why the weather alters.
Cool, but I need to give it transparency. So, is there a transparency option? Alpha channel. Let's make it 255 divided by 4. Okay, how's that? And that didn't come through at all. Hang on. Still good, man. We're still sorting out technical difficulties anyway, so you won't be missing anything. Hope you're enjoying the annotation of the technical difficulties of OBS. Let's try 75. Okay. That's not strong enough, so we'll make that 150. Okay. I think. Let's have a look. So if I switch back to, could be a little bit darker. Okay, I'll make it a little bit darker. So we'll make that 175. Oh, hang on, I'd actually switch to main. Just a little bit more darker, and I think we're really ready to go. Whoops! I showed my Twitch stream. My Twitch. I better close that, so I don't get data mined. Okay, 200. Okay. Let's check to main. Yep, that's good enough. Okay. So, right. I think we are all set to go. I'll just quickly check my color theme. What happens if I go tap as light? You can't see that. No, let's try normal light. Now that looks good. No, hang on, light plus plus. Now that looks even better. Okay, cool. But I'll switch back to dark because I've always noticed that Windows has bad text rendering compared to Mac. I prefer Mac's rendering. So looks good, but we'll just stick to that. Cool. Right, now I actually need a drink. So I'm gonna go and set up a drink for myself. Oh dear, my Spotify. I had to fix my music list. Oh, look at that. Oh dear. Okay. Filters. $6.50. $6.25. Make it 1150. 60. 70. 1180. Yeah, I think it works. So I go back to my Unity. Yeah, that works. Okay. So, thank you for being patient. Thank you for being patient, everyone. I believe we are actually ready to go. So I'm just going to quickly get a drink, and we'll start programming the next version of the avatar. Okay. Right, let's get started. So, where we left off last time, now that I'm actually moving forward to the stream after sorting out all the technical difficulties. We got our cube, and it looks where the mouse is at, which is really cool, and you can see it in the bottom right. Today, we want to, so what I'm going to do here is I'm just going to create a new folder called doc. The assets, I've got a new folder, I'm going to call it doc. It's all, we're going to outline what our goals are. So, new file, plan.md. Now, MD files are fun, right? Goodbye, don't save. Goodbye, don't save. MD files are fun. Markdown files are like pretty much a text version, a text editor. Markdown guide. Free and open source reference guide that explains how to use Markdown with simple and easy to use Markdown that you can use to format virtually any document. Syntax, basic syntax. So yeah, basically like it allows you to program actual documents, which is really cool. You'll see that if you go to let's go to GitHub. Doom. That's the only thing I can think of at the moment. Do they have a good README doc? No, they do not. Okay. GitHub. To do example. Cool. So you see here, I'm on GitHub, and by default in GitHub, there will usually be readme.md, and it's basically like the introductory document to the project. In this case, but what the MD file is, an MD file, so I open that up separately. It is an actual text document, so if I go raw, it's just normal text, right? But it's like has a special syntax to be formatted into actual headings and bullet points and like code blocks and stuff like that. So it's really, really useful. And we're going to use that because it's just like consistent. So we're going to give it a basic syntax. Like here, your headings, you just put hashes and you get different heading labels. Paragraphs. Line breaks. Yeah, if he's bold, you just put, yeah. It's just like, yeah, it's, I love Markdown because like I get to write full documents without opening up Word. And we're going to use that to outline our plan for the day. First things first. Oh, it is using Markdown. Okay, cool. Plan. So everything. Let's write down. Oh, you're back. I really wish the Twitch stream had timestamps so I can see how long I've missed this message for. So let's write down the milestones we want to do with this Twitch avatar. Milestones. Let's add some spaces. So we know that we want an awesome Twitch avatar. Actually, no, let's not call milestones. Let's do this differently. Let's call this requirements. Requirements for a project. Requirements. Is that how I spell requirements? My spelling's really bad. There is one... what? One requirement. So we wanted to look at the camera. At the mouse. Timestamps. Oh! Timestamps for the chat. I'd love to get that. Click for cog, chat appearance, timestamps. Oh, it's so useful. Oh, thank you so much. Oh my god, thank you. That's given me such a help when I'm responding to chat. Thank you. And there's an emoji that I can't see. Anyway, so we wanted to look at the mouse. We want it to feel smooth, and I'll show you that. That's probably something we can do today. We want eyes, obviously. We want a mouth. We want to give it a texture. We want to give it props. We want to give it idle animations. So what I was thinking is, like right now, when my mouse is completely still, the cube's just staring directly at the mouse without moving, and that's boring. You know, that's boring. We wanted to do something more than that. So at some point we'll add idle animations, and that's gonna be fun because then we could probably look into a bit of like object-oriented programming there. Props texture. Programming stream. We have indeed started a programming stream. Interesting BG. What's the BG at the end of that? Typo. Boo. But the good news is you missed most of the technical difficulties, so I got most of the technical difficulties out of the way. So since you guys are here, I'm listing. Yeah, perfect timing. Like I went through a lot of trouble to make sure that it would line up with the Unity editor correctly. Since we're here, I've written down my requirements for my amazing Twitch avatar. I think now's a good time to like float some ideas in the chat. So if you hit us, if you guys want any, if you guys think my Twitch avatar should have any special features, now's the time to say it, because I'll write it down in the document. You too. Companion cube skin. So we're going to skins. So we'll make it skins. Characters. Minecraft. Disney themed. Nothing will go wrong there. Like I'm actually tempted. I actually am tempted. Characters, Minecraft skins. Cool. So the cool thing is I can flip back. I can flip back and forth. I can flip back and forth between So like if I can between the document file and the rest of the code. So as you move forward in the stream, if you guys have any ideas you want to add, just go ahead and add them. But I think we have enough to start now. So let's work on making it feel smooth. So the issue we have today is, if I move really fast, it moves quite fast. And I'll show you a good example of what I mean. I'll actually go to Twitch and I'll actually look at my old stream because I have a really good example of this. So if I find Delivery 421.
It's actually a miracle I kill anything, right?
Ha! Well, no, we didn't. No, hang on. I'm not a narcissist. I'm trying to look at another video. So if I go to my channel, videos, StarCraft playlist. Just turn that down. So do you? Yep. Hang on. Where's a good example? Okay, if you saw that, what's happening is the cube is locked to the position of a mouse. So what happens is in my StarCraft streaming videos, when I use my hotkey to select buttons on the bottom right with the mouse, my Twitch avatar springs to the bottom and then springs back. And so that needs to be smoothed over a period of time instead of just being assigned directly. So that's what we're going to do today, and it's my favorite part of game programming, actually. This sort of like programming smoothness to things. So let's begin with that, making it feel smooth. So if I go back into my code, just a recap of what we did in our cube behavior. Last time on the stream, we figured out a function in the user 3-2 DLL that would give us the position of the mouse and screen coordinates outside of the window, and that's how we're able to make the cube look at the mouse in absolute screen coordinates, because the limitation we have with Unity is the default Unity framework only gives you mouse coordinates relative to its own window. So that's what we did last time. So we have this nice update function. I'm going to start deleting things. We have this nice update function that that would do that. But now we want to smooth it out. And so what that means is instead of assigning the rotation of the transform to the to the rotation inferred from the mouse, we're going to do it differently. So transform.rotation equals lerp. No, hang on. Quaternion lerp from where we are to where we want to be. So I'm just going to break this up a bit. So lerp from here to here, and I'll explain lerping in a sec. Hang on. Oh, I need to give it a position. So for now, 1. Actually, we'll go time.delta time. So before I go into the Unity editor, to explain what lerping is, sorry, to show what I've just done, I'm going to explain it in Paint. And I bloody hate Paint. Is there something better than Paint? We'll go with it. We'll go with it for now. So lerping. Right. Let's say we have actually, let's say Critter. I do like Critter. Well, I rephrase. Like, I love the promise of Critter. It looks nice. Actually, let's try Critter. Don't save. Oh. Critter. And it's going to take ages to load. Because we only want what is it? We only want yeah, no, let's just stick to Paint. We only want like small technical diagrams. So lerping is you have 1, then you have 10. So you have two numbers, 1 and 10. So you're at 1 and you want to get you want to progress towards 10, but not completely, right? So let's say you only wanted to go like 40% towards 10, right? So you're not going the entire length, you're only going about 40%. That's what lerping is. Actually, I'll just let's see how Unity describes lerping. Linearly interpolates between 2 points. Yeah, so that's pretty much what it is. We have 2 points. We have a point over here, and we have a point over here. And we don't want to jump over to the point. We want to find a position between the point over here, or over here, or over here. And so that's what lerping is. And so what we're doing here is we're using a quaternion lerp. So that's a lerp that we use for the quaternion type. And just to recap, the quaternion type is a helper class for rotation math. Rotation math is a pain. No one likes doing rotation math. It's a pain. So what we want to do cool. Yeah. I'm glad I helped inform that. The quaternion lerp, it just says lerping but for quaternions, pretty much. And so basically we have 2 points in the lerping space. We have our current rotation, and then we have a rotation of our mouse. And the last step to do that is to give it a percentage. In programming, you don't give percentage in between 0 and 100. You give it between 0 and 1. Right? So 0 would be 0%, and 1 would be 100%. So 0.5 would be 50%. But I'm not going to calculate how much I want to do it, because there's a really fun trick I just go time.delta time. So now if I could jump back here into the actual Unity app and I rerun it. See that? It's a lot smoother. So I can do that and it moves towards my location like slowly but also smoothly, right? So what's happening here is with a looping function, you give it a percentage between 0 and 1, or 0 and 100, of how far you want to move between the 2 points, right? Time.delta time, if I print this out, let's print it out. There's a really nice, in string programming, in string passing, there's a really nice feature in C# where if you put a $ at the beginning, you can then inject other values into the string. So I can say delta time equals, and then I use these 2 brackets here, and then I put in time.delta time. Right? And I'll come back to like this sort of $ a bit later, but like just it's so useful when I'm debugging. So if I print out, if I go back into here and if I rerun, click on console and I hit run, we'll see what delta time is at. Delta time is always clear, like it's always 0.01. So delta time is always a fraction. So what that means is if I was to delete everything, so we have our 2 points. The point over here. Whoops. No, we want bloody paint. We have a point over here and we have a point over here. What we want. So we know that delta time is like a small fraction of a distance, right? So we're here and we want to get here, but only a percentage. So that's our percentage. Cool. Next frame. Now we're here. Next frame, now we're here, and the next percentage is here. Next frame, now we're here, and the next percentage is here. Next frame, we're now here, and the next percentage is here. And so, like, we always slowly move towards our goal. But as we slowly get there, each frame, it starts to slow down like this. And the reason is because we're always, in each frame, we're always moving a percentage towards our target, right? Based on where we currently are. But if you think about that, like the closer we get, we'll start doing this, right? So we won't get there. Kind of, we won't get there 100%, right? But that's fine because like. For visual purposes, it still looks pretty cool. So it doesn't matter if it gets there 100%. And the reason why I prefer this method is because we avoid state management, right? So in programming, the concept of state management, basically, I'll open up wide. This is another tool I like to use to visualize things. Okay, new document. In programming, the concept of state management is you have all these things, you have all these systems inside a program, and these systems will have its own internal state, right? It's, you know, so earlier I talked about variables, right? A variable is its own state, right? This square has its own internal states. 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 Generally, we want to minimize how many states we maintain, right? So I could go and program like managing the state between 0 and 1 between the various frames, but I don't want to. I'd rather just grab the mouse position, do some processing, and then have it look smooth and not worry about maintaining variables, right? So it doesn't really matter that we'll never ever reach 100%. It doesn't really matter, we'll never ever reach 100%. It still looks nice, and it keeps our code concise. I'll give you another example of what I mean. So I'll go back into the code, and I'll write another function. I'll add some to let's add a variable a equals 0. We'll make it float. A equals 0. Float b equals 10. And then in the update loop, I'll just go a equals mathf lerp from a to b based on 0.1f. Right, so in this case, we will always, every frame will be moving a closer to b by 10%. Right, and then I'm going to debug it. A equals, I'm just going to comment out this one. So if I refresh, you'll see that, so I'll just pause and we'll scroll to the top. So you'll see that A starts at 1, then 1.9, then 2, then 3, then 4, then 5, then 6, then 7, then 8. And it gets to 9, but then it never gets to 10. And it kind of gets stuck here, right? Because it can't finish getting to 10, right? And that's because we're not going from we're going from where we are to 10. We're not going from 1 to 10. We're going from where we are to 10. So we're always grabbing 10% from where we are to 10, and we're moving towards that. And then on the next frame, we go from where we are to 10 by 10%. And so, like, yeah, it's like it's like, yeah, it's like curved, but we'll never ever reach 10. But again, that's fine, because visually we don't see it. Like, it doesn't become an issue visually for us, and it still looks cool. So if I hit play again, like if I look in the center, my cube visually is looking forward, so it's fine. It's not an issue that we never quite get to 10. But what I will do is I will add a spring to it. So currently we're just taking the time.delta time fraction. We don't want to do that. So I'm going to create another variable here. So I'm going to create a public variable. I'm going to make it private actually. Private. I'm going to say serialized field. I'll explain what this is in a second. Float spring. And by default, I'll make it equal 5f. Now, this is an attribute in C#. So if I go to C# attribute, so all attributes are attributes describe metadata of fields, of things. That's it. So on the C# level, attributes just describe things, right? In this one, DLL import return Marshall as, those mean specific things in the context of running an application Windows, but in the context of C# itself, we're just saying that this is metadata that belongs to the get cursor position function, right? So in the obviously here, DLL import user32 and Marshall, that's saying that the following function belongs to that DLL, and Marshall as, I'm not entirely sure exactly what that is, but it seems to be it seems to be like how it gets interpreted when it comes into the C# context. Same down here, structured layout kind of sequential. This is saying that the order of we're going to take the order of information and apply it linear from top to bottom is my best guess. But what I'm trying to say is when you see these square brackets in front of a field, something, can't spell. When we see this in front of a field, we're describing metadata correlating to the member variable or the function or the class, and some other part of the system is going to use that metadata for something. In the case of Unity, we have serialized field. What serialized field says is the following member will be able to be serialized by Unity's inspector, right? So if I'll just give it a capital S. Go on, Spring, thank you. So if I go back into Unity, let it recompile, click on cube behavior, you'll see it says Spring. So we have the Spring field, but it's private. So if I remove the serialized field and go back into here and then recompile, Spring disappears. We can't edit it. So serialized field tells the inspector that while this is private, we still want you to serialize it. And this brings us to public and private. So let's discuss public and private. Got my nice wide visual editor, node editor. Make that dark. Go dark, please, thank you. So what public and private is, if things are private, so let's say this first square is the class, and then we have these other squares inside it. All public and private means is things inside, but if it's private, things outside the class cannot reference private things inside the class. And if things are public, things outside the class can reference things inside the class, right? So down here we got private vector free starting cube rotation, and then we've got a public vector 2 mouse range, and we've got a public vector 3 range. So starting cube rotation, nothing outside the cube behavior class can touch that, right? But mouse range and range, they're both public, so they can be touched outside the class. So going back to wired, like these are public, and these are not public, they're private. So I'll make this like dark blue, right? So what that means is another entity can edit these things of this class, but can't edit this. I'll make you red, and I'll give you a no-no, right? So this entity cannot access this member, but it can access these members. So these are public members, and these are private members. But obviously there's an exception to that, and that exception in Unity is serialized field. And all serialized field is saying is that while this member is private, we do still want to serialize it in the Unity inspector, right? Spring. Okay, so that's public and private. So we're going to go back. We're going to put time.delta time times spring. I will let it recompile. I'll hit play. So we can see now it's a lot faster, right? It's a lot faster. And it looks really good now, like it's nice and smooth. And you can probably see the difference between the cube that I have running in OBS and the cube that I have running in Unity. In fact, I just better let's do that. So that's better already. Like that just feels so much better already. And that was only like 1, 2, 3, 4, 5, 6, 7 lines of code. Yeah. And again, I like indenting like this because if I wasn't to indent, like this is how long the line would be. Like look at that. That's not readable at all. So I like to indent it out so that it's like your eyes don't have to travel that far to get to like figure out what this is. So if I turn the spring up, if I turn it down to like 0.1, you'll see that the cube's really slow to turn. Really slow. Have I rotated the cube? The cube doesn't... Hang on. No, it looks fine. So if I was to go back and make that like 0.01, maybe just 0.1, that's too low. You'll see that the cube is really slow to turn. Like really slow to turn. Do you see that? It's rotated. What the hell? It's tilted. So I'm just gonna break this out a bit. The desired rotation equals so that's a vector 3 and that's a vector 3. Okay, that should work. Just make sure Z is 0. We do not want any rotation to happen on the Z axis at all. So we'll go from our current rotation to our desired rotation. So, play. Yeah, that seemed to fix it. Cool. Yeah, so if I make it this 1, oh, do you see that? Oh, but when I put it, oh, we'll worry about it later. It seems to work. Put it at 1, it slows down, and if I put it at like 100, it's really fast. So I like to call this a spring because it's acting kind of like a spring. So I set it to 4. Yeah, so we'll leave it at 4. Yeah, I like that. Cool. So I can build that, but in order to build that, I need to actually shut down my cube for a second. So I have to hide the stream for a moment. My apologies. Building my new cube. My new cube is built. That looks a lot better. Whoops. Okay, so what? Cool. Okay, so what should be next? So we'll go back into my roaming, my plan. So we're having a look at the mouse. We're having it feel smooth. Eyes. Let's give it some eyes. Eyes should be simple. It's materials. For now, I'm just gonna create a base material. A material. Make it like dark. Not entirely dark though. Are you guys having fun? So I'm going to create a new. Cool. Well, I hope you're having fun. If you're not having fun, then I have failed my mission. Eye material. Well, we've got a big C here, so we'll just make that smaller. Now, I am not an artist, so my placement of the eyes will be very problematic. Well, that will change. The more I talk, the more you'll learn. I shall hack your brain, and you'll become a programming wizard like me. No, I'm kidding. So I'm going to download a reference. Unity, Minecraft, head cube texture. So I am not an artist, so I'm going to steal some textures to use as a reference for where to place the eyes of a mouse. To Minecraft Steve head cube texture. Where can I get a nice head texture? Unity. Head. Minecraft character. Because all I want is I want to just grab a Minecraft head texture to use as reference. No, I don't want a massive texture pack. Unity Minecraft Steve. Sketchfab. download links. No, don't want to create an account. Bugger. Free download. Pirating models is my favorite part of game programming. Ah, for fuck's sake. Oh no, here we go. I want you to log in and create an account. Hang on. This is a really cool site.
We don't have much money.
Free game assets. Open game art. Steve. Cannot bloody spell. Search. Close enough.
So what?
Oh, this is a texture pack. It's on a model. Well, let's download it anyway and see what it looks like. The artists of the audience, do you have any recommendations? Like, all I need is a nice reference of Steve's head, so I know where to place the eyes. You know what, I'm overcomplicating it. We can come back to this after I actually get it working. So so we'll come back to, like, I can fix the positioning later, and actually that's a good programming exercise to set up the actual functionality to work without a reference, and then we can bring a reference in later and then we can adjust it. So I actually think that's a good idea. So that being said, yeah. So we'll come back to setting up a reference later. So let's go back into my plan. What do we want the eyes to do? We want the eyes to be there, right? That's simple. But we also want to blink. Right? Do we want them to look? We'll make that a what if. A nice to have. So let's start with the, just putting the eyes there and blinking. I'm already like halfway there. I'm going to change these positions because, like, I'm going to change these positions later because they just don't look nice. I don't know how to make it look nice. Are they the same? If I go over here, orthogonal. Yeah, it's the same. No, one's slightly. That should be the same now. Okay. So obviously that's not going to work because if it play, like, the eyes don't move with the cube. Simple fix. Putting the cube there. Wait, what? Oh, it's the wrong cube. That's the wrong cube. So now we have the eyes look with the cube, but that looks so bloody creepy. My God. We'll fix it later. So I'm actually going to rename this eye anchors. So this one will be the left eye anchor. And this one will be right eye anchor. And the reason why I did that is because we actually don't want, we want an anchor, because if we come back and we do the eyes, we don't want the, we want to like do as many things with eyes as possible and feel confident that they stay in the same place. So I'm going to remove the, I'm going to remove all of the components from the anchors. And then I'm going to create a child on that instead. I'm going to see and put another one on here, but zeroed it out. So here we have like the actual eyes themselves are zeroed out, and the anchors that they have are in the correct position. So we'll just put the eye material back on. And you know what? Actually, I'll make this a prefab. I'll clean up the folder structure later. But what we can do is if I zero this out again, what it means is I can go into the prefab, change what it change the prefab structure. So in this case, we'll make the make it a bit bigger. And now they both change. That looks so creepy. I don't like it. Oh well. I'm gonna have to hire one of you artists to kind of like fix the look of it once I get programming a bit more. But until then, we'll just deal with creepy eyes for now. Looks so creepy. Yeah. So I've created the sphere. The actual eyes are the spheres, but the prefab down here, so I can change this prefab. And then, yeah. But now, I'm gonna make him blink. How am I gonna make him blink? So, I'm gonna create a new script called eye behavior. And in the script, so basically I wanted to blink at random points in time to make it feel a little bit more alive and not so dead, right? So I'm going to have one behavior that controls controls an eye, and then I'm going to control that behavior from the cube behavior. So in this case, eye behavior, it's going to have an eye behavior component will have two fields. It will have one root for its open eye, another field for a closed eye. Right? And we'll have two functions, public void blink. No, we'll call it open. No. And we'll have another function called closed. And it's very simple. When you open, we turn off the open eye and we turn on the open eye. And we turn off. No, IntelliSense, go away. and we turn on, no, we turn off the closed eye, and then closing, open, close. Closing is the opposite. We turn off the open eye, we turn on the closed eye. Yep. So again, how this is going to work. So if I go into scenes, scripts. I'm going to put this down into assets. Create a new folder. Prefabs. Gonna put this here. Rename iPrefab. Go into here. So this iPrefab, I'm going to remove all its components again, and you'll see why. So remove component. I'm going to add iBehavior, but I misspelled. No, I do not want a new script. I want the iBehavior script. And I'm going to create a child seer, and I'm going to give it the same material again, the I material. So we're going to call this open eye. You can call this the close eye. Now I'm going to turn this off. Turn this off. I'm going to turn the close eye on. We're going to change its vertical scale to be like that. And I think like that a little bit. Now going back into here, I'm on private, awake, thank you. So on awake, I'm going to say debug assert. Now this is just like to help the debugging process. All this is doing, debug.assert, is I am checking to see if it is assigned. So if it does not equal null, if this condition fails, it's going to print this. Open eye not assigned. Same, I'll just copy that. And so all this is doing is it's going to help us developers just maintain awareness that we have things assigned correctly. And I'll show you that a bit later, but for now in the prefab, open eye, close eye. And I'm just going to make sure that in awake, by default, we run open. Cool. So if I go back, you'll see both my eyes are now closed. That still looks creepy. My God. We'll make it work. We'll make it work. I believe we can make it work. But what it means is I can go into the iPrefab and like maybe make this a bit taller. And they both change. Actually, I think what I should do is on the root, make the root flatter. So if I hit run, they open. Okay, so we're going to, so that's the eye behavior. Now we don't want the eye behavior to control itself. Sorry, rephrase. We don't want the eye behavior to dictate when things open and close. We want the cube behavior to have a responsibility. But now we have a situation where the cube behavior is doing multiple things, which makes sense because it's kind of like the root script that does everything. So I'm just going to clean it up a bit. We're going to create another function, update mouse look. And we're going to move all of our code that takes the mouse position and like moves the cube to the right position. We're going to move it down here. I'm just going to go update mouse look. And the reason why I'm doing that is because we have, for readability, we have this central function here called update. But we can't, so all things will be called through this update function, but we don't want this update function to be like 10,000 lines long. So like, well, we can't not have things be called through the update function. So basically, the different things we do in the update function, we're going to break down into their own functions. And it's just for readability sake. So the next function we're going to write will be void update eye blinking. And that's what we're working on. So what does it mean to blink? Well, we'll be blinking at random times, right? So I'm just trying to think. So we'll have a float blink countdown. No, so our first variable is last blinked time. And that'll equal 0. So what this variable will be, this variable will act as a timestamp of the last time our character blinked. Right? Next one. This starts simple. So we have that like variable done here. I'm going to add another variable up here. And again, it'll be a serialized private float blink time. And by default will be 1.8. So this is very simple. If time.elapsed if time.elapsed time, no, if time.time is bigger than last blink time plus blink time, then last blink time equals time, and we're going to need a reference to our eyes. So we're going to have an eye array. So we're going to have another serialized field. But this time it's a private eye behavior array. I'm going to call it eyes. So actually, we're going to have two states. We have open and closed, which means we have two times. So I'm going to add another variable. We have blink countdown. I'm going to change this to blink countdown time. We're going to have blinked. And then we're going to have blink duration time. Let's say this is like 0.2. time.time, last blink time. Now, the issue we have is we're waiting for the blink countdown to finish, then we blink for duration, then we open our eyes, and then we go through the cycle again. So now we're in a situation where we have time management. But time management and programming is pretty tricky. Because code executes once every frame, right? Code executes once every frame, but we want code to execute at specific points in time. So we have two options. We can program a bunch of Boolean statements, or we can write a coroutine. So I'll show what a coroutine looks like. Routine. I'm going to go yield break. And so here we go for each eye behavior I in eyes. Now, eyes dot close. So we close all eyes, but before I continue, I'm going to get rid of these brackets because we're only going to do one thing in this for each loop, and I'll explain a for each loop in a while. But for now, we're just going to focus on the blinking. So so first we close all eyes, then we're going to yield return wait seconds. And we're going to wait no, we're going to wait blink duration. Blink, well, hang on. Blink duration time. I'm actually creating a class. And we're going to turn our eyes, open our eyes again. Okay, so I'll explain what an enumerator is, and I'll explain what coroutines are. So the issue with the code is we update, the code executes once every frame. Update, 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 update. It gets called once every frame. So then we had to do time management, but then we could program Boolean flags so we know what state things are in, but that gets very bloated very quickly. And we don't really want to do that. So we have this thing called an enumerator. Now in C#, an enumerator function does this as yield in the it does not. When you use the yield contextual statement, you indicate that the method operator or get accessor in which it appears is an iterator. Using yield to define an iterator removes the need for explicit extra class. So in C#, you notice here that I went for each eye behavior I in eyes, right? So eyes is a array. It's an array of an eye behavior, which is our own script over here, right? And I showed you for each, right? So in a loops we have a standard, we have a while loop, then we have a for loop, then we have a do while loop, and then we have a for each loop. and before each loop's really convenient. So if I was to write a function, if I was to write a loop that was to go over, like let's say index 0, index smaller than eyes.length, index plus plus, and then inside here I go eyes at index dot open. That's a lot of extra code. That's a lot of extra code that we don't need because we just want to iterate over the collection that is eyes. And that's why we have the for each loop, right? So that the for each loop, use wide. The for each loop, the for each loop is designed to make iterating over collections really, really easy to write, because we don't have to write index, 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 index. We just go, we can just go for each type instance in collection. Debatable. So there's two things, right? Like as a programmer, it does get physically, like there's a time associated with how many things you write. And oh, we have 5 years now. That's cool. And so there's three factors. There's how long it takes you to write the program. There's how many errors you make when you're writing the program. There is how easy the program is to read for others, and there's how easy it is to change for others. So with the for each loop, I'll just undo before. So with the for loop, you can very easily make mistakes, because if you have like for each and then you have another, if you have a for loop and then another for loop inside the for loop, and then you have another for loop inside the for loop, you have to maintain like JDEX, WUDEX, ZDEX. You have to maintain all these index variables, right? And that can get problematic very quickly, because not only are you maintaining the variables, but you're maintaining the row increasement, right? And you can very easily make a mistake for something as simple as iterating over a collection. So in the case of iterating over collections, they invented the for each loop to make it a lot easier. They created the for each loop to make it a lot easier to just do that simple operation where like on each element in an array. So that's why the for each loop exists. I would argue less code makes a better program because it's more concise. It's more concise, it has less surface area, it's easier to edit. Oh, I lost my 5 viewers. I had 5 viewers for a moment and then disappeared. Oh well. So I'll go back to here. So yeah, what the for each loop does is if we have a collection of elements, it will run this for each of these elements. Like that. But it also assign each element to what we have here. So each element is assigned to I. And it means we don't have to like manually do this. I's index open. So it's a lot more concise. But going back to coroutines and iterators, an iterator, it's a bit of a hack. So like I'll write another iterator. Iterator, do thing. What have I done? Whoops. Do thing. Yield. Iterator number. Yield 1. Yield return. No, return. Yield return. 1. 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I can do is I can go for each. I'll just uncomment the yield break so I don't have that compile error. What I can do is I can do for each int number in do thing. What? What? I don't have this wrong, do I? I'm just checking the documentation because oh, it has to be a numerator. Numerable. Okay, that's confusing. So you have an iterator and a numerable. Anyway, but going back to the yield 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the function gets treated as the function gets treated as kind of like a collection. But it means we can do stuff between elements in the collection, like so like I go into here and I write debug.log. Put in 1, 2, 3, 4, 5, 6, 7, 8, 9. Nine. So it means between collections, between items of a collection, we can do stuff. And like you'll do this, and then this, and then here it yields back to here, and I can do things in here, and then it goes back to here. So like it kind of pauses the function, gives access to the pauses the function, does some other thing, and then returns to the function. So that's cool. But for Unity, it means Unity's created this amazing hack, which I love, called coroutines. And so they're essentially using the same functionality that the yield statement in C# gives you, but in this case, they attach it to time. Right? So here, how it works is we do we go for the for loop and we close the eyes, and then we yield return until these seconds has passed. Right? So this function, this enumerator yield function, it pauses here for a duration of seconds, and then it resumes. Right? And that simplifies the blinking programming. That simplifies time coding a lot. Makes it a lot more straightforward, makes it a lot easier. It makes it a lot easier to manage. And it also means we don't have to worry about state management, because state management's always problematic. Now, there are situations where you want to do state management. I was on a project recently where we avoided state management for a system, and then we realized we should move back to state management. So there are situations where you want to revert to state management. But in this case, we don't want to do that. So how it'll work is update eye blinking. If a time is bigger than the last blink time plus the blink countdown time, we set the last blink time to now, and I'll explain this logic here in a second, but then we go start coroutine. And in the start coroutine we go routine blink. Yeah, so let's go back into Unity and watch this happen. So what are my default times? The countdown time is just under 2 seconds. Blink times is like 20% a second. So let's have a look. Let's see how this goes. Oh, I've not assigned my actual I need to actually assign my eyes. So here we now have a nice eyes array we can assign. So we have my right eye. We have my left eye. Hit play. And we have blinking. But the next issue is like it's too uniform. So that's even more creepy. Right? That's even much more creepy. So let's go back to our planning document. And let's figure this out. Blinking. How can we make blinking feel natural? Well, the time between blinks should be random. And then the amount of blinks at a blinking session, that's a fun name, should also so we want to make it feel natural. So now we have the next step is like the time between blinks should be random, and the amount of time at a blinking session, amount of blinks at a blinking session should also be random. So what I mean by that is like you blink, every time you blink, like sometimes you blink once, and other times you blink twice. So we're gonna see if we can mop that up using code. So we don't just have a countdown time, we also have a variation, blink countdown variation. So we're going to increase this to, let's say, 3 seconds, but then we're going to make the variation a second. Right? So if I go back, update eye blinking. We're going to have another variable called serialized. No, actually, no, we don't want this serialized. We actually want this to be legit private. Next, blink countdown equals. We don't have a time yet. So in the update eye blinking function, we're going to go next to blink countdown equals blink countdown time plus mathf just math random. Now we had to go Unity engine mathf random. Where's the random function? What happened to the random function? Oh, we moved it out of math. So let's go random. And we're going to take the blink countdown time negative. We're going to take the negative version of it and the positive version of it. We still got a error. What is it saying? It's a class. Is it a static class? No, but it does have static functions. Okay. And again, it's going off a page, so I'm just going to do this because I'm weird and I like weird formatting. I prefer this opposed to one big long line. So then we're not checking last blink time by blink countdown time. We go next blink countdown. So that should give us variation. So if we go back into Unity, make sure there's no compile errors. Queue behavior, blink countdown time, variation. Okay, so let's hit play and see what happens. Blink. I think it's random. Yes, it's random. But it's still a bit too... So we're going to change the countdown time. We're going to change to, let's say, 3. And we're going to change the variation to 2. Okay, let's change it to 5. I should change it to 6. How often do you blink, guys? $182. Wait. Have you been counting how much you blink per day? I think it works. That's funny. For variation 3, it still feels a bit unnatural too often, so I'll make it 10. Variation of 4. Blink. Blink. Okay, I think that works. That looks good. The next thing though is we want to have a random time. We want to have a random amount of blinks each time we have a blink session. So the next thing is we have blink duration time, we're going to make that 1. We're going to have blink wait time. No, blink session duration time. We're going to have blink session wait time. And then we're going to have blink session amount time. No, actually, it's not a time. Blink session amount. And this is going to be an int, not a float. Hang on, I just got to check something. 2. Make it 3. So blink session duration, and then we go wait. Blink session wait time. Okay, and then so this is where it gets fun, and this is why I love coroutine. This is why I love coroutines. So at the beginning of a coroutine, int session blink amount equals Unity engine random. I like putting the Unity engine at the beginning before random, so we know that we're using the random function from inside Unity, because if we wanted to, we could use a random function provided to us by the .NET runtime. But there's some variation there. The .NET runtime works a bit differently from the Unity random, I think. Range 0, 1 to blink session amount. Right, so we essentially want a random amount of blinks. So then we go, because we do have a number and not a collection, we do use a standard for loop. Index, actually we'll call it blink index equals 0, as long as it blink index is smaller or equal to the session blink amount, then blink index plus plus. Meter up. So let's run that and see how it goes. I'm going to bring it down from 10 to 6, no 4, so that we can see it a lot more faster. But I do prefer 10. So hit play. So now we're blinking multiple times. But still, maybe we might change that from 2. Okay, so we blink twice, but do we ever blink once? So what's happening here is him blinking, we're never blinking once, we're always blinking twice. So why is that? This changes from 1 to 0, and I'll explain why in a sec. Because I think it rounds up. One blink. Two blinks. Two blinks. One blink. 3 blinks. I thought I set that to 2. Oh no. We want to okay, so we're gonna move that equals. So since we're counting from 0, if our session blink amount is 2, we go 0, 1, 2. So that's 3 times. So that's 3 instances from a number of 2. So in the programming we count from 0 a lot. So 0, 1, 2, 3. But obviously in the human world we count from 1, 1, 2. We had to keep it in mind. So the mistake I was making was I was counting from 0. So session blink amount would be 2, but I go 0, 1, 2. So I'm making that, but we can fix that, it's easy. We just go smaller than. So smaller than, so we have smaller than, we have smaller and equal. The difference between the two, right? If my value is 1, and I'm checking to see if it's smaller than 2, that will turn true. But if my value is 2, and I'm checking to see if it's smaller than 2, then that gives me a false. And that's counterintuitive to a lot of people when you start, because you assume that 2 and 2, you get a true, but you get a false, because the operation says if it is smaller than, and by definition 2 is not smaller than 2, 2 is exactly equal to 2. So that's why we have the smaller than or equals to sign. And for any programmers in the audience who are thinking, oh that's a small trivial thing, that really caught me off guard when I was learning, when I was beginning. Yeah. So that should make it. That should even it out a bit. So we'll hit play. 2 blinks, 1 blink. One blink. Come on, blink. Why aren't you blinking? Blink. Single blink. I mean, it's working, so let's consider that working. We'll set that back to 10. Well, actually, now that I think about it, 8 might be a bit better. Blink, please. Validate me and blink. Blink, goddammit. Okay, so I'm very suspicious of that, so I'm going to debug this. So every time when I blink, we're going to debug.log. We're going to go blink sesh. We're going to blink session started. Blink session. Blink session started. So we should eventually see another blink session started. Blink session started. Blink session started, but I didn't blink. Why did I not blink? I blinked. So what I'll do is go to the blink amount. I'm just going to debug log what the blink amount is. Put the $sign in so I can print it out quite easily. You know what? I'm going to set the time to 2, variation to 1, so that we can debug this a lot faster. One, 0. We should never have 0. So we're going to make this 1 again. Okay. Someone say something. I'm getting bored. In the chat. Something. Yay. Something. Okay, so we have blinking working. But I'm never getting. Okay. So. Let's try that out. So sometimes we blink once and sometimes we blink twice. There you go. It's looking good. I'm going to remove his logs. I'm going to restore that back to the countdown time. We'll make it 8, and then the variation will make 3 seconds. And I will recompile because I want to see that. I'm just going to hide my screen for a second so I can edit my setup without you guys seeing all my private data. But, you know, I'm still here. I'm just rebuilding my cube, and I had to shut down the app to do it. And we're now at 5 viewers. Whoever just joined, say hi. Look at that. So now I just have to make sure he pops up in my... There you go. Blinky Bill. That's a good name for him, actually. I think we'll call him that moving forward. Blinky Bill. So I'll just switch back to my main. Whoops. We now have 5 viewers, so if you feel inclined, please say hi in the chat. I am starting out and I'm hoping to grow. Yeah, my avatar looks a lot better now. He blinks and he looks smooth. The next thing I want to do is when my mouse is still, he's too still. So if I go back into my dock, my plan. So I was going to do this later, but I'm going to do a little bit of it now. So idle animations. So 1, we want them to be a bit of movement. 2, if the mouse is still, we want to look away from the mouse. And then we look at random positions. And then we want to have like fun animations that get triggered by chat. So that last one's going to be really fun, but we're not going to be doing that today. The bit of movement I want to do today, because that's something I can do, that will, that's something I can do that's quite easy to implement. So what I'm going to do is I'm going to go back to the cube behavior. So what I'm going to do is I'm going to break the movement of my cube off from the cube behavior into its own class. And you'll see why. Oh, do I need to? Actually, no, I don't. Before we do that, actually, because we should keep the amount of classes in our project as small as possible. Before I go ahead and do that, let's see if we can do it in the scene hierarchy. So if I go back here, the one change I will make is in the cube behavior, I will specify a root object. So serialize field, private transform call it root. And instead of adjusting the transform, when I go transform, instead of adjusting the transform, I'll go root dot, well, I can just go root. So where else to go transform? You can go root. Oh, we now have 6 viewers. Feel free to say hi in the chat. Yes, I am counting each viewer as they come, because that's how desperate I am for viewers. Just slowly counting away. Transform. Okay, so if we go back into the scene hierarchy, we want to decouple the actual cube from the root of our character behavior. Right? So what we're going to do is first I'm going to copy this, copy component, and then we're going to destroy it. Move component. Right? Next, I'm going to create a child on here, create empty, but I'm going to move this child out of the parent. I'm doing that so I can preserve the position of the object. I'm going to call this character root. No, character base. And then I'm going to create an object underneath that called root. I'm going to drag the cube onto that root. And on a character base, I'm going to write add component. I'm going to click on the dot dot of a transform. I'm going to go paste component as new. And here's my behavior again. So I still have blinking? Oh, no, I don't. I have not assigned the root, and you'll see that I've been getting this error. The variable root of cube behavior has not been assigned. So, I'm going to assign the root to that. Cool. So I've preserved all my behavior. Don't have any errors. Why aren't I blinking? I was blinking before. Blink. Where's the next blink? Blink. Cool. But I want there to be a slight wobble or like shift in the cube's root. So I'm going to change this. I'm going to call this geo root. I'm going to switch this from root to geo root. I'm going to close a bunch of tabs I don't need anymore. So what I want, yeah, I don't want the cube to be completely still. So what I'm going to do is I'm going to scroll out a bit. I'm going to create a duplicate cube, move it over here, and we're going to set the we're going to use the animation window, and we're going to animate it. Animation. Put it down here. I select here. To begin animating cube, create an animator animation clip. Create. So I'm going to create a new folder. Animations. I'm going to call this cube idle animation. So what I'm doing, Unity does have some animation support, so you can animate objects inside Unity. Cube animation idle. Now it creates two files. It creates an actual animation file and it creates a animation controller. So first we'll focus on the animation. First we want to lock the animation window. We want to click, we want to hit record, and we're going to go and rotate, and we're going to rotate the cube ever so slightly. Just slightly over here. Slightly over here. And then slightly up. Whoops, I need to do it down here. Slightly down. Move it back a bit. Cool. So we have a precursor to our animation. But it's just a bit too fast, it's a bit too strong, but now we have the keyframes. So we're going to open them up. So we're going to make this free. I'm at -3. You know what? I'm going to delete all this and start again. So we're going to do it in numbers. Because I'm a programmer and I like numbers. Thank you very much. Start at 0, let's say after 5 seconds. Y rotation, -4. You know what, I'm going to do this programmatically, and I'll explain why. So, what I've been trying to do is usually my preference in Unity projects is anything that can be offloaded to the animation system or to the scene hierarchy, it's best to do that, right? And the reason is when it comes to code, writing code to do rotation, position stuff is highly problematic because if you have to go back and change it because oh, we need to change, can we move it to the left a bit? To change it, you have to go into the code and change numbers. And it becomes difficult. So anything you can offload to the animation system, you should. But in this case, me trying to animate it is actually going to be too complicated because I'm not an animator, and it'll be wonky and it'll take up more time. So we will actually do this programmatically. So I'll go back and I'll delete all of this, and we'll delete this cube because we don't care about it anymore. So I'll go back to my root cube. My nice character cube. Is my audio working? My voice? Yes, cool. So we are going to do this programmatically, but I want to keep this separate from a cube. So we're going to go back into the scripts and we're going to write idle animation behavior, but I can't help but misspelling. So we have cube behavior, and then we have idle animation behavior. So this will be really simple. We're just going to have, actually we want the update. I don't know. No, we don't. Yes, we do. Vector, so we're going to have a private vector 2. That'll be our range. Then we're going to have a private float. And that'll be our countdown. So we're going to have private void update. Privately, we're going to have vector 2 next desired rotation. And the next desired rotation, leave it blank for now. So update new rotation. So update rotation countdown. There's a better name. Update rotation countdown. Wait. Is my cube working? Yes, it is. I thought my cube wasn't working because again, my screen's delayed, and my screen's delayed, and I have my mouse in the center of the screen. Update rotation countdown. Private. Void update rotation. And we're going to add another property. We're going to go serialized field transform root. And we're going to call those both of those functions. Update rotation. So we update. So again, privately, we're going to have float last update timestamp. So if, and this is the same thing as before, if time.time smaller than, no, if it's bigger than last update town plus countdown, then we're going to set this to any of those scopes. Last update time equals the current time. What else? We want a new we want to calculate a new rotation. So that's easy. Equals a new vector 3, no, new vector 2. Gonna space it out. MIDI engine dot range, random range between negative range dot x, positive range dot x. And that should be our next... What? Oh, whoops. Put random in, and it's supposed to be range. So here we're just calculating a new... Here we're just calculating a new... I'm a bit of fixed at spelling. I'm bad at spelling. This is just our next position, and then an update. We're going to do it. We're going to another one. We're going to add a serialized property. Private spring, private float spring. And we'll just go. You know what? I'm just going to copy the code over here because it's a similar type of code. It's just doing it on a different transform with different properties. So here we just go next desired rotation based on the spring. Okay. So and this is why we have individual components, because we can start to we can keep things localized to different routes. Whoops. Wait, what have I done? Where's my character? What have I done? Here we go. We want the route to go here. Range, let's say 5 degrees, 5 degrees. Countdown, let's say 8 seconds. 12 seconds. Spring, we want to be really low, so let's put it at 1. That should work. So I can keep my mouse completely still, and he should move. Okay, maybe the spring's too small. So what we'll do is we'll set the to 10, and we'll set that to 10. Any questions, anybody? Okay, we're going to sit down. We're going to test it. I'm going to set it to 2 and spring to 2. Oh, it's working. Oh, I have it the wrong way around. Current rotation to next desired rotation? No, that's correct. So I need to make the, let's make it a bit more aggressive. Let's make it, the range, let's make it 45 degrees. Now that's weird behavior. He looks away. Are we using different routes? Geo route and normal route. I'm just going to create a new cube just for debugging purposes. Whoa! Oh! Local rotation, not world rotation. So what was happening was I was using the world rotation, not the local rotation. Check that out. So now, like, if I keep my mouse completely still, he looks around automatically. But obviously, we want to tone that down. So what we'll do, go back to the character base, make that 1515. How's this? Okay, let's make that 10 by 10. Now I'll make it 15 by 15 again. But what we'll do is we'll make a spring a lot smaller, so like 0.5. And lastly, we will make the countdown 8 seconds. So I'll make the spring a little bit more aggressive, and we'll make the range like 25 by 25 instead. Nah, it's too much. We'll make it 15 again. I think it's looking good to me. So what's happening? Basically, what's happening is this root is looking at is rotating according to the position of my mouse, but then this root is just randomly like. And I can show you if I create a cube here. This will look buzzy as hell, but you will see that like every now and then they will move together. So like it creates a bit of an offset, which makes it feel a lot more natural. Yeah, I'm liking that already. I'm really liking this. Okay, I'm pretty happy with that. So I'm going to do another build, which means I have to hide my stream. So I'm just building again. And if I run it again, I'm just looking at it now on my screen, so hang on. Oh, there you go. So I'm just watching my stream on the side to see how my cube behaves. But it looks a lot smoother now in terms of its motion. And it's blinking. Oh, the blinking looks so cute. And I can see the cube looks a bit to the left and right, even when I keep my mouse completely still. Which is very useful. And it's very simple for now, but later I'll look more into like some sort of special state management. Yeah, but that looks a lot better. Okay, shall we tackle audio? So going back to the plan, the next thing to do we want to animate the mouth a little bit. So obviously we want to make it respond to audio input. So let's look this up. Unity mic. Microphone. Uses this class to record an audio clip using a connected... No, we don't want to. We don't want to record. We just want to get the volume. Mic volume. So what do the forums say? Okay, so he's using the API. What API is he using? Ah, perfect, mic input. What is mic input? Mic input. What is mic input using? Microphone devices. So devices. So what do you use devices with? So devices is a string array. But what do you use it with? Oh, this person's recording. So when does it call stop? No, I do not want to save. Stop microphone. Without recording. We do not want to record. Get position. So I go back. Get the position and sample of the recording, but we don't want to record. We do not want to record, we just want to get the volume. Oh, they start the clip, but not. Are they actually recording? Let's try it out. And we can always look at the memory. So I'm going to create a new mic capture behavior. So microphone gives you devices. So first of all, devices equals new equals microphone cough microphone devices. Devices we're going to do for each in print. Debug, nope.
Have the regular opportunity to prove your fitness to provide. I know a lot of regular kids wound up in jail.
New keyboard. Well, I wouldn't call it new, but yeah, my ergonomic keyboard is like super amazing. Okay, so we're just gonna drag this onto the character base down here, and it's just gonna give us a list of the devices that we can see. Okay, cool. So we can see those. So the next step. How do the people online did it? But let's go start, but actually don't go record. Clip record. What is clip record? It's an audio clip. Okay, so we're gonna create an audio clip. If it's proves to be a memory leak, we can always stop it and start it again. So when we start, we go microphone start device, microphone dot start, and it says it's asking for device name, a loop, length seconds, and a frequency. Okay, it's just gonna go. First device. So to clarify, I have one ergonomic keyboard at home, and I have another ergonomic keyboard at work. So Microsoft ergonomic keyboard. Ankles. What? So this is the one I have at home, and this is the one I have at work. So I had this at work, and it's been super helpful at work before lockdown. And then when we went into lockdown and transitioned to my home office, and I started using this one, which does look expensive, but I'm a nerd, so I'm allowed. And I've been using this for most of the lockdown, but I've kind of got sick of it, so I've switched back to this keyboard now, and the key travel is a lot better on this one. This is still a good keyboard, but what I've noticed is I have to switch keyboard like once every 3 weeks. Yeah, so that's the situation with the keyboard. Ankeys. What does Ankeys refer to? Gonna copy this magic value. So we start it. I'm going to debug log its get data. I'm just going to copy this function because I'm lazy. But I'll talk through it, what it's doing. Sample window. What is sample window? Oh, okay. Clip record. This is clip. We just want to print out level max. Okay, let's test that. Now, I am worried about a memory leak, but there's ways around it. Testing. We have a null. Null reference. What art thou null reference? So if you do not have a clip, actually no, I need to create a new clip. So we'll just have start a clip here, new audio clip. And if we do not have a clip, we just want to abort. So if audio clip, no, if clip equals null, then we want to return 0. Pardon me. Oh dear, what have I done? Okay, so it seems the class just doesn't have a audio clip. Oh, so that's annoying. But they're doing it. Why is it giving me an error here? That doesn't make sense. Because it would be null already. Oh no, actually no, that does make sense. But they are creating a clip here. This is what I don't understand. Okay, let's just go serialized private. We'll go back into here. We'll create a dummy audio clip. Create. It's not going to work, is it? Well, let's ask Unity. Let's ask Google. Unity, create audio clip. Audio clip.create. Dummy, we want you to be I don't know what the frequency should be. No. Length samples. I'm going for 1,000 for now. I'm not entirely sure. Channels 1. Frequency. Stream true. Okay, so let's try it again. Testing, testing. Still get a null reference for a null an error. Not allowed to be called from mono behavior constructor or instance field initializer. Okay, sure, we'll do it here then. Hope you guys are still having fun today. despite the complicated programming and terrible presentation skills I have. Testing, testing. Okay. So cannot get data from streamed samples for audio created by AudioCreate. Okay, so that should be false. Chill coding. True. Testing, testing, testing. Okay. So the next error is executing result equals instance sound lock. Let's have another look. Unity. Get mic volume. You know what? I'm just going to copy this. Whoops.
This is only the
What am I doing? I'm just going to copy all of this. Evil coding, evil coding, evil coding. We're going to paste it in. And then we'll talk through it. Bye. And we'll call this, change this to mic.
No further details available at this time.
Mic capture behavior. And we run into the same issue we had before. You cannot create an there's no new constructor for the audio clip. So it's obviously an outdated example. 2016. So we need something relatively new. Oh, you don't actually use it. It returns an audio clip. Okay, that changes everything. So we'll undo. I'm so stupid at times. We'll undo my copy and paste. That can equal null. That can equal null. Clip can equal the. So we'll go back to here. Testing, testing. Testing, testing, testing. Testing. I think it's working. I mean, so it's obviously working now, but the value's so small, like the value's so unbelievably small that it's hard to measure. Testing, 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 testing. So what is that? So it's obviously seeing things. It's obviously seeing things, but the question is like, how can we convert that to 0, between 0 and 1? Actually, what I'll do is I'll look at my OBS. See how that decibels. So does it start negative and move up to like 0? Is that how it works? Let's ask. Let's ask Google. dB to 0, 1. Unity. Anything in that context. Well, what happens if I divide by 0? I mean, no. Not divide by 0, divide by 20. We don't want to divide by 0, I could crash my entire computer. Testing, 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 testing. Testing, 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 testing. That's not really doing anything. I mean, it's working. I'm getting, I am successfully getting volume input. But the next step is to get that into a format that's workable. So right now it's an absurdly small value. And then when I speak, it goes down to 0. And like that's just, I find that confusing. Like I find that really confusing. This is old. This is all JavaScript version. But let's see if I can copy it in. Let's get rid of this. Oh, come on now. I don't know if I... We'll just add this actually down here. Float. This is a really old script. This is from like the Unity script days. If max, we're at val, if max. Thank you. And I'm gonna change it to float. We want to assume it's a float. Change this to a float array. Well, that sucks. Does it no longer exist? No. Oh, you need a source. That complicates it. That complicates it a lot. Animate mouth from mic. I'm trying to find the fastest way to do this without like learning too much new stuff, because all we want is a normalized value between 0 and 1 so we can move on to other things. Just gonna quickly watch this YouTube video on stream. I'm gonna take it volume of mic.
It may even surprise you to know that I have positive proof.
This is a point in time I'm going to be really quiet. Just because. What? An array list? What? Let's try this.
The heat ray they emit from their mouths is more powerful than anything yet known to man.
Say, don't you think it's strange?
Okay, let's see what that does. Testing, testing, testing. It works! But I will put this in a try catch. So what try catches allow you to catch errors, and I don't want the I don't want that error to like be problematic down the line, so I'm going to return 0 if it's the case. We will debug log it though. Cool, so when I speak normally, seems to go up to about 1. Okay, so we got that there, so the next step is to animate. So make this public. Get rid of that. So I might as well, now that we have a working version of the code, I might as well talk over how it works. So first, so what it's doing is it's reading through the samples from the audio clip that's being used to record audio from the mic. It does it quite complicatedly. We declare our samples here, we declare an array, and then we get a starting position in the microphone. Hang on. You know what? I might just explain this on another stream. I don't really care. But essentially, what it's doing is it's scanning through the last set of audio samples, getting its peak, and then it's just returning that. So let's go back to our queue behavior. So we're going to have a reference. We need to give us a reference to a mic capture. So serialize field. Actually, no. We want to break this off. So what we're going to do is we're going to create another script. Mouth behavior. So it's going to be very similar, serialized field, private, transform, open mouth, close mouth. We're going to assert debug. We are going to assert that they are assigned and then an update. It's going to be very simple. We need a reference to the mic capture behavior. Float volume equals mic capture dot volume if the volume is above if it is smaller than 0.5 and we're going to have it show the methods open close. On open we actually return the open mouth. Turn it on. We turn on the open mouth. And we turn off the closed mouth. You can tell I over-rely on IntelliSense. So if volume is bigger than 0.5, we open. If it's more than 0.5, we close. Now we just have to create our mouth. So on the actual character root, giga root, we're going to create a new cube. But this time, oh, hang on, I just had to check something. My phone. Okay, I'm back. We're going to turn this extra cube into the mouth. So I'm going to do something different. Instead of scale, I'm going to do this rec control thing. So if you there's Q, W, E, R, T. W is position, E is rotation, R is scale, but then T is also scale, but allows you to drag it around like this. It's a lot more easy. It's a lot more easier. In this case, spheres are mouth.
We were riding in the cemetery.
Well, it's 8 o'clock and it's still light.
Actually, you know what? I'm gonna undo this. I'm gonna remove a cube. But I will add a gizmo so that I can see its position. So this will be the mouth anchor. So this is the mouth root. So now we can turn the scale down. This looks awful, but whatever. You know what? I'll disable cast shadows because that's making it weird. I'll give it the same material. What have I done? Give it the same material as the eyes. Again, it's 0, 0, 0. So this is the closed mouth. This is the open mouth. The open mouth will be bigger but shorter. And I know it looks terrible. I know it looks absolutely terrible. So what I'll do is closed mouth, open mouth. Let's see how that goes. Testing. Testing, testing, testing. Testing, 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 testing. Okay, let's debug this out because that doesn't make any sense. That needs to be F, of course. I think after the mouth, once I get the mouth working, I think I might call it there. Smaller then. Okay, let's see how it goes. Testing, testing, testing. It's not making a difference. So is the volume coming in? Debug volume. Oh. I had that condition the wrong way around. Oh. What? It was working before. What happened?
Can I see you a minute, please?
Testing, testing, testing. Testing, testing. Testing, testing, testing. Like, that's coming through. That is coming through. But it's 0 when it gets...
Leave the car here.
What am I doing? Testing. What? That doesn't make any sense. So when it gets called internally here, it works, but when it gets called externally, that does not make sense. Haha. Yeah, no worries, man. I hope you have a good afternoon. I hope you enjoyed the stream today. Okay, so that's really weird. When it gets called from outside the class, it returns 0. That does not make sense. Oh, wait. Yeah, but that doesn't make sense. So remember lowercase v. Yeah, that's the idea. Chilled programming streams every Saturday, assuming I don't get burnt out from work.
Very good.
Yes, it does. Yes, what are you talking about? You do exist. Ah, needs to be uppercase. Okay. Oh, it's working. I think it's working. That's pretty cool. But it's a bit too aggressive. I might change it. Instead of a C point. First of all, I'm going to remove that. Second of all, I'm going to remove these debugs. If it's bigger than 0.3, is this working? Oh, it's working! It actually works. Although it's a bit weird, so maybe 1. Testing, testing, testing. And it works. It works! My cube totally works. Over the mics, I think, like, it's hard to tell if it's for mic or if it's the yeah. Just thinking. Like, as I speak normally, it jumps back too much. So let me just think, but until I do that, actually, it will be cool. Is if I... Oh. Okay, so I'm going to compile. So I need to hide. Need to hide the stream. And it works. Look at that. My cube is reacting to my mouth. But I can set it up. I should probably set it up where like it kind of like goes up and down a bit, because it kind of jumps back and forth too fast between a closed mouth and an open mouth. So I'm going to add a little bit more functionality to kind of like ease it up a bit. So let's do that. Okay, so I'm back. So the issue is if I go into my, when I'm into my code, if I go into back to into my code. So in the mouth behavior, private. Okay, it doesn't hear my fingers tapping, that's good. Last value. lost volume. So last volume.
Women prowls around the streets all hours of the night, just like an animal. Maybe he's the man. Don't start any gossip with that cricket.
So so we're going to go mathf.max. So we want to get the bigger of two values. Either we get the volume or we get... So what max does is if there's two values, 1 and 2, it will return 2. So it returns the bigger of the two values, right? And then we wanted to go equals math.lerp. We wanted to lerp back down to 0. So lerp from itself to 0. And we'll create a spring. So serialize field private float spring. Testing. Testing, testing. Hello. Testing. Okay. So we're going to turn that spring down a bit. Testing. Haha. 0.1. Testing. Look at that. That looks a lot better. But make it be 0.5. Testing. 1. Testing. Hello, hello, hello. That looks really good. Like how it's responding to my voice. It looks really good. How about now? Look at that. My voice is working. Awesome. Awesome, 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 awesome. Okay. So I'll just quickly compile that, and I'll again I'll replace. Whoops. I'll replace my the cube on the stream. So I'm just building my new cube. Look at that. Now that's looking really good now. Oh, is it? Hang on. Hang on. I'm just checking. Testing. Testing, 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 testing. It's a bit too aggressive now. So we'll go back to the mouth controller. Yeah, it's too aggressive. So make it 0.1, 0.1. Testing. Testing, testing, testing. Hello. Okay. 0.2. I think 0.2 is looking good. Yeah. I think 0.2 is looking good. If I make it 0.15. Testing. 0.1. Testing. Hello. How are you today? Yeah, it's looking good. For now. Okay, so I had to remember 0.1, so now Disable play. Copy 0.1 back in. Just double check that. Hello, testing. 1 2 3 1 2 3 1 2 3. Testing. Hello, my name is Reverie. Still feels a bit too aggressive. Oh, no it doesn't. Okay. Yeah, we'll roll with this for now. Maybe 0.5. Oh, I have an issue. I didn't times it by time.delta time. Times time.delta time. Okay. Let's try it again. Testing. Haha, that's far too slow. Testing. Okay, it's far too slow, so let's do 5. Testing, 1 2 3. Hello. My name is Reverie and I like to program. Yeah, I think that it looks good. I think it's looking really good. I think it's looking really good. So the value is 5. And we'll just hit build settings, build.
Herman prowls around the streets all hours of the night, just like an animal. Maybe he's the
I'm sorry you got over that, Klingon. Everyone knows where it might end.
Testing. Oh, that looks really good. Well, we made a talking cube. It's looking good, guys. Thanks for sticking by. Looking really good. I'm going to do another stream in like 3 minutes because I want to test the cube out with StarCraft. But I think we're good to end there. So thank you everyone for making it a pleasant stream. I look forward to the next stream. You guys have a good day, have a good afternoon. Yeah, I hope you've learned something new about programming. Yeah, it's pretty cool. Right, TJ out. Oh shit, I said my real name. Oh well.